Guys, Miss Smith here. This is our study guide for our end of the unit or end of the module assessment for fractions, Module 5. We're going to just jump right in, starting with question number 1. Gabe and Robin eat waffles. Their waffles are the same size. Gabe eats 2/3 of his waffle. Shade the rectangle to show how much of the waffle Gabe eats. So in fractions, this bottom number is our denominator, and it tells us how many pieces my object or my whole has been partitioned into. And the top number is my numerator, and it tells me how many of those pieces I actually have. So we are shading 1, 2 of the 3 pieces to show that fraction 2/3. Part B, Robin eats 1/3 of her waffle. Shade the rectangle to show how much of the waffle Robin eats. So again, she also has sliced hers into 3 pieces, but she only eats one of those pieces, 1/3. So we're going to shade that. And then we have a comparison statement. Circle an answer choice from the list to make the statement true. So Gabe eats more than Robin. I'm going to circle Gabe's name because he ate more. If it helps them to actually fill it in to make sure that that makes sense, that works as well. Question number 2, Eva draws 4 shapes. Eva partitions the shapes as shown. Circle the shapes that are partitioned into equal parts. So one of the big ideas of fractions is that we can't have fractions unless we have equal parts. We need them to all be the same size as the parts that they're partitioned into. So if I look at these, even though these are the reverse image of one another, if I were to fold that over, these are exactly the same shape and size. So these are 2 equal parts. The same thing here, I have 4 equal parts. These pieces are much smaller, so those don't work. These pieces are smaller than that, so this does not work. Write one answer from this given answer choices in each blank to make true statements about Eva's shape. So her first shape was a triangle. Each part of the triangle is, and this would be 1/2, and this would be 1/2. So it is 1/2 of the whole. Each part is 1/2 of the whole. The second shape we circled was a square. So each part of the square is 1/4 of the whole, because each is one of 1, 2, 3, 4 pieces, 1/4. Question number 3. Which fraction does the point on the number line represent? So we've talked a lot about fractions are between intervals. Intervals represent the space between whole numbers. 0 is a whole, 1 is a whole. So everything that comes between there is in that interval. This interval has been partitioned into 1, 2, 3, 4, 5, 6 pieces. So the first thing I need to look for is something that shows a denominator of 6. And then I want to double check. This is the first or one piece out of 6. So her point on the number line was at 1/6. Number 4, Adam partitions a rectangle into 4 equal parts. So I always encourage students to read, think about what's important, and draw. So I'm going to stop after this first sentence and think about that. Adam partitions a rectangle into 4 equal parts. So the first thing we need is a rectangle. And then 4 equal parts, we talked a lot about how to partition equally. With fourths, we're going to half, and then we're going to half those pieces again. Then I'm going to read on. He wants to color 3/4 of the rectangle blue. How many parts should Adam color blue? So for that, I'm going to grab my blue, I'm going to color 1, 2, 3 of the 4 pieces blue. So basically, they're just wanting them to understand the numerator tells how many of the partition pieces that I actually have. So Adam colors 3 pieces. I can see that in my picture. Number 5, partition each whole number interval into fourths. Okay, so I'm going to stop right there. Let's talk again about some vocabulary that maybe you're not as familiar with from when you went to school. Again, these are whole numbers. They're the numbers that we count. They have not been made into any kind of fractional pieces. Okay, so from here to here is an interval. From here to here is an interval. So the space between each whole number is an interval. So when they tell me that I have fourths, that means there needs to be 4 pieces in this hole and 4 pieces in this hole. One of the things I showed my students who were struggling with this is to think about it if you were partitioning or making fractions from brownies. When I begin at nothing, I don't have a brownie yet. I have no brownies. But if I bake 1 whole brownie, here to here represents that whole brownie. It's a brownie. It's in a hole. I'm going to erase my interval line. If I bake a second brownie, from here to here is a second brownie. This represents 1 whole. This represents 1 whole. But if I put them together, I have 2 whole brownies. We're going to cut our brownies into fourths. Again, talking about partitioning, we do halfway. So I'm going to do a halfway mark between 0 and 1. And then we half the halves to make 4 pieces. But that's only 1 brownie. This number line shows 2 whole items. So I need my other brownie to be partitioned into fourths or 4 whole pieces. So we're going to half the brownie and then half the halves to make 4 equally partitioned pieces. Okay, so that's where we have to begin. We have to partition in between each interval in the correct fractional unit. Then we can count. If I had no brownies baked yet, I have 0 of 4 pieces. If I had just this piece, I have 1 of 4. If I have these pieces, I have 2 of 4. If I have these pieces, I have 3 of 4. If I have these pieces, I have 4 fourths, or 1 whole brownie. I have all 4 pieces. If I get an additional piece from this other brownie, I actually have 5 fourths. And if I were to get a 6th piece, I would have 6 fourths. So they're going to put a dot on their number line at 6 fourths. One of the common mistakes students will often make is they will start at 0 and count it as 1/4. I try to remind students that when you were here, there was nothing represented yet. 0 means there's nothing. So we need to make sure if the interval begins with 0, that we are labeling that fraction as 0 fourths, not as 1/4. All right, number 6 is all about students understanding how we compare fractions. We cannot compare fractions unless the fractional units are, not the fractional units, but the whole is of an equal size. So in this example, I have a small circle and I have a large circle. Because I have something that is small and something that is large, this cannot be compared because it's not a fair comparison. Any piece that I make from here is going to be smaller because the whole started out smaller. Any piece I make here is going to end up bigger because the whole circle was bigger. So the big idea is when the whole amounts are not equal, I cannot compare them. It says, Pablo says, my picture shows 1 of 6 pieces. 1/6 is greater than 1 of 4 pieces. Is Pablo correct? As I was just saying, no, this is not correct. And I would just simply say, you cannot compare fractions unless the whole amounts are the same size. So I would need 2 circles that were this size to compare, or 2 circles that were this size to compare. When you start with a whole that is not of equal size, you cannot compare them. Number 7. Deepa wants to compare 9/3 and 9/6. Label 9/3 and 9/6 on the number line. This was one of the most challenging questions our students had so far because the number line has already been partitioned for them. So between each whole number or each interval, it has been partitioned into 6 pieces. But it also is asking for them to be able to find where the thirds are. So one of the big ideas that we talked about as a class was the relationship between related fractions. Related fractions have something in common, just like you have something in common if you're related to someone. Thirds are a bigger fractional unit. Those pieces would be bigger. 1/6 would be smaller. If I were making my very own number line, and I had the number 1 and the number 2 and the number 3, and I was asked to do thirds, thirds would be here. And then from there, because thirds and 6ths are related, we have learned that we can half those in order to make 6. I'm going to stop here because we've got some students coming in.